Have you ever gazed at the moon and wondered how far away it truly is? Well, let's delve into that. You see, the moon, our nearest celestial neighbor, sits at an average distance of about 238,855 miles away from Earth. Now you might be wondering why I said average. That's because the moon doesn't orbit us in a perfect circle. No, it follows an elliptical path, which means sometimes it's closer and sometimes it's farther away. Imagine yourself on a roller coaster, reaching the peak and then descending into a valley. That's kind of what the moon's orbit looks like. At its closest approach, known as perigee, the moon is about 225,623 miles away, but at its farthest point, or apogee, it's about 252,828 miles distant. Now here's where things get intriguing. You see, the moon isn't just content with orbiting us in this elliptical manner, it's also gradually, and I mean very gradually, moving away from us. Yes, you heard that right. Our moon is slowly but surely distancing itself from our home planet. This isn't just a hypothesis or a theory, it's a fact confirmed by laser beams bounced off reflectors left on the moon by the Apollo missions. Each year the moon is slipping away at a rate of about 1.5 inches. It doesn't sound like much, does it? But over hundreds of millions of years those inches add up. So, the moon, this beautiful object that has inspired countless poems, songs and stories, is slowly drifting away. But don't worry, it's not going anywhere fast. It will continue to be our faithful companion for a very, very long time to come. So, what exactly is propelling our lunar neighbor away from us? Well, for that, we'll need to delve a little deeper into the science behind the moon's movement, but that's a topic for our next scene. Stay tuned! To understand why the moon is drifting away, we need to delve into the science behind its movement. In the cosmic dance of the Earth and the Moon, gravity plays the lead role. Our planet and its lunar companion are locked in a gravitational embrace that dictates the moon's orbit around the Earth. Gravity, as you may know, is the force that attracts two objects towards each other. In our case, the Earth, being larger, exerts a stronger gravitational pull on the moon, keeping it in orbit around us. The moon's orbit around the Earth is not a perfect circle, but rather an ellipse, with the Earth slightly off-center. This means that the distance between the Earth and the moon changes as the moon completes its orbit. At its closest, known as perigee, the moon is about 226,000 miles away. At its farthest, known as apogee, the moon is about 252,000 miles away. Now let's introduce a new character to this cosmic dance, the sun. The sun's gravitational pull on the Earth is much stronger than that of the moon due to its massive size. This tug of war between the sun and the moon causes the Earth to bulge slightly, resulting in tides on Earth. Here's where things get interesting. The Earth's rotation and the moon's orbit are not perfectly synchronized. The Earth spins on its axis about once every 24 hours, while the moon orbits the Earth about once every 27.3 days. This difference in timing generates a bit of friction between the Earth's oceans and its crust, known as tidal friction. Tidal friction acts as a sort of brake, gradually slowing the Earth's rotation. As the Earth's rotation slows, conservation of angular momentum demands that the moon's orbit must expand, causing it to move away slowly from the Earth. This doesn't mean the moon is packing its bags and leaving us in the dust. The rate at which the moon is drifting away is approximately 1.5 inches per year, about the same speed at which our fingernails grow. But over billions of years, this small annual shift adds up. 4.5 billion years ago, when the moon was formed, it was about 15 times closer to the Earth than it is now. If this trend continues billions of years into the future, the moon will be significantly farther away, changing the appearance of the moon in our night sky and the nature of tides on Earth. With this scientific background, we can begin to understand why the moon is drifting away. Tidal friction plays a crucial role in the moon's gradual departure from the Earth. As we delve into the heart of this matter, it's important to understand what tidal friction actually is. Simply put, it's the frictional force caused by the gravitational interaction between the Earth and the moon. This gravitational tango between the two celestial bodies creates tides in our oceans, and it's where the story of the moon's slow dance away from us begins. Imagine the Earth as a spinning top, and the moon as a tiny dancer twirling around it. Now, the Earth's rotation causes the ocean tides to form a sort of bulge, a little bit ahead of the line directly between the Earth and the moon. This tidal bulge, in turn, exerts a gravitational pull on the moon. This is where tidal friction comes into play. It's the result of the Earth's rotation and the gravitational pull of the moon on the tidal bulge. This creates a drag effect, slowing down the Earth's rotation slightly. Think of it as a gentle brake applied to the spinning top that is our Earth. But here's the kicker: for every action, there's an equal and opposite reaction. That's one of Newton's fundamental laws of motion. So, as the Earth slows down, that lost rotational energy doesn't just disappear. It's transferred to the Moon, pushing it slightly faster and into a slightly higher orbit. Now, when we say slightly, we mean it. It's a process that's happening at a snail's pace, with the Moon moving away at a rate of about 1.5 inches per year. That's about as fast as your fingernails grow. But remember, slow and steady wins the race, and over billions of years this process adds up. So the Moon continues its graceful waltz, moving to a higher and higher orbit, all thanks to the power of tidal friction. This process, though slow, is unyielding, and it's been happening since the Moon first formed about 4.5 billion years ago. All of this might seem a bit abstract, a bit distant, but it's happening right now, as you're listening to this. Every second, every minute, every year, the Moon is getting a tiny bit farther away from us. It's a cosmic ballet choreographed by the fundamental forces of nature, a silent testament to the ever-changing nature of our universe. In essence, tidal friction is the invisible hand gently nudging the Moon away from the Earth. It's a powerful force, one that shapes our planet and our Moon in subtle yet profound ways. And it's a reminder, a humbling testament, to the grand scale and unfathomable timescales that govern the cosmic dance of celestial bodies. Over billions of years, this process has been pushing the Moon ever farther from the Earth. The Moon's departure from the Earth has intriguing implications for our planet. As the Moon continues its slow dance away from the Earth, it leaves subtle but significant changes in its wake. One of the most noticeable effects of this celestial waltz is the gradual lengthening of our days. Now, just to clarify, we're not talking about a sudden shift from 24-hour days to 25-hour days overnight. This change is happening at a glacial pace, almost imperceptible in human terms. Each century, the day lengthens by a mere 0.002 of a second. While this might not seem like much, over billions of years, it adds up. Imagine a time billions of years from now, when the Earth's rotation has slowed so much that our days are significantly longer than they are now. It's a mind-boggling idea, isn't it? But it's a real possibility if the Moon continues to drift away. Yet the Moon's departure doesn't just affect the length of our days, it also has a profound impact on our tides. As the Moon moves further from the Earth, its gravitational pull weakens, leading to less dramatic differences between high and low tides. This could drastically alter coastal ecosystems, which rely on the ebb and flow of tides for their survival. But before you start panicking about the impending tidal apocalypse, let's put this into perspective. These changes are happening over such a vast timescale that they won't significantly affect humans within our lifetime or even within the next several thousand years. In fact, it's estimated that it will take billions of years for the Moon to drift far enough away to cause these dramatic changes. So while these shifts won't impact our daily lives, they do have fascinating implications for our understanding of the universe. They remind us that even the most seemingly permanent fixtures in our sky are in a constant state of flux. The Moon's slow departure from the Earth is a testament to the dynamic, ever-changing nature of our cosmos. It's a humbling reminder that we are part of a vast, evolving universe where even the smallest changes can have profound effects over time. It underscores our need for continued exploration and understanding of our celestial neighbors and the universe at large. So the next time you gaze up at the Moon, remember that it's not just a static object in the sky, it's a dynamic part of our universe, slowly but surely drifting away from us. Yet even as it drifts away, it continues to shape our world in subtle and profound ways. While these changes won't impact us directly, they give us a fascinating insight into the ever-changing nature of our universe. So why is the Moon moving away from the Earth? Let's take a moment to reflect on the journey we've embarked on today. In the grand cosmic dance, the Moon, our closest celestial neighbor, is gradually pirouetting away from us. This is a phenomenon dictated by the laws of physics that govern our universe, a ballet composed of gravitational forces and the Moon's orbit. We explored the Moon's elliptical orbit around the Earth, a path sculpted by the gravitational tug-of-war between these two celestial bodies. We learned that the Moon isn't just spinning aimlessly in space, it's locked in an intricate waltz with the Earth, a dance that's been choreographed over billions of years. Then we delved into the science of tidal friction. This is the frictional force exerted by the Moon's gravitational pull on the Earth's oceans, creating our familiar tides. This interaction causes a slight delay in the Earth's rotation, transferring energy to the moon and propelling it to a higher orbit, ever so slightly increasing its distance from us. It's a slow process, but over the eons, these small shifts add up. We also contemplated the potential consequences of the moon's gradual departure. While it's not something we'll witness in our lifetimes or even in the next few thousand years, it's a fascinating thought experiment. The moon's absence could lead to a more unstable Earth, with significant shifts in climate and even the length of our days. The moon's journey away from us is a reminder of the dynamic and ever-evolving universe we are a part of. As we continue to explore and understand our cosmos, who knows what other surprises await us. The tale of the moon's slow departure serves as both a testament to the laws of physics and a humbling reminder of our place in the cosmos. It's a story that's still being written, and we're all a part of it. So let's keep looking up, keep questioning, and keep exploring. Because in the grand scheme of things, our journey is just beginning.